15 billion miles from Earth, where the Sun is just another bright star in the distance, Voyager 1 drifts silently through the black. For nearly half a century, its faint radio whispers have told us the story of its journey. Stable, predictable, almost routine, until now. NASA has just confirmed something unexpected. A strange new signal, unlike anything the probe has ever sent before, has reached Earth. It's not static, it's not random noise, and it's not any of the regular data mission control has been receiving for decades. Scientists are calling it an anomaly, but what that really means is simple. They don't fully understand it yet. Could this be a symptom of a failing system? The first sign that Voyager 1 is nearing its final moments? Or could it be evidence of something entirely new? Something in the unexplored vastness of interstellar space interacting with our most distant explorer? Whatever it is, it has already changed how scientists are looking at the mission, and the closer they examine it, the stranger it becomes. Voyager 1 launched in 1977, a bus-sized probe with a record, a camera, and a plan. First stop, Jupiter, then Saturn. It stole speed from those giants and slingshotted for the edge of the solar system. Along the way, it sent history, volcanoes on Io, the rings of Saturn in razor detail, and in 1990, one last look back, the pale blue dot. After that, the cameras went dark to save power. The mission didn't. In 2012, Voyager 1 crossed the heliopause, the Sun's magnetic boundary, and slipped into interstellar space. No other human craft has gone farther. Today, it's over 15 billion miles from home. The Sun is a bright star behind it now. It runs on 3 nuclear batteries called RTGs. They fade a little every year. Engineers shut off heaters, reroute power, and nurse a few key instruments, particles, fields, and plasma, just enough to keep learning. Its voice is a faint radio tone, aimed by a 3.7-meter dish. We catch it with Earth's largest antennas. A single message takes nearly a day to reach us, and almost a day for our reply to get back. That's the stage, a tired but stubborn explorer, still reporting from the dark, which is why this new signal matters so much. It's coming from a place only Voyager knows, and it doesn't fit the script we've known for decades. For decades, Voyager 1's signal has been like a steady heartbeat, predictable bursts of data wrapped inside a faint carrier wave. Engineers at NASA's Jet Propulsion Laboratory know it so well they can almost hear it just by looking at the graphs. But this new signal, it's different. Instead of the usual crisp digital packets, the carrier wave now carries a strange, low, rolling variation, almost like the hush of an ocean wave, rising and falling in a slow rhythm. Some describe it as a constant whooshing sound if you were to convert the radio tone into audio. It's not random static, and it's not the kind of data corruption they've seen before. The anomaly first appeared during what should have been a routine systems check. An engineer monitoring the Deep Space Network noticed an odd fluctuation in the signal's baseline, a subtle but unmistakable deviation. Within hours, the team had confirmed it wasn't a ground-based glitch or interference from another spacecraft. This was coming from Voyager 1 itself, across the endless gulf of interstellar space. At first, the control room reaction was quiet. That kind of heavy silence when experienced engineers know they've just seen something out of the ordinary. Then came the rapid back and forth, pulling old data for comparison, cross-checking antenna systems, and looping in the small group of specialists who have been keeping Voyager alive all these years. No one is ready to say what it means yet, but everyone agrees on one thing. This whooshing signal is a first in Voyager's 48-year history, and that makes it impossible to ignore. When an anomaly like this shows up, the first step for scientists isn't jumping to the wildest explanation, it's working through the most likely ones. And with a 48-year-old spacecraft like Voyager 1, there are plenty of technical possibilities to examine. It could be a fault in the probe's transmitter. The high-gain antenna that's been whispering back to Earth for decades might be drifting off calibration or experiencing power fluctuations. Another candidate is cosmic radiation. Out in interstellar space, Voyager is exposed to high-energy particles that can occasionally flip bits in its memory or disrupt sensitive electronics. And of course, there's the simplest explanation of all: aging. Many of Voyager's systems have been running far beyond their original design life. A slow degradation in onboard hardware could easily create an odd, unfamiliar signal pattern. Then there are environmental factors. Voyager is in a part of space we've never explored up close, the boundary region beyond the heliopause. Here, the Sun's influence fades, and it meets the raw interstellar medium. Rare, high-speed particles, strange magnetic structures, or even shock waves from distant stellar events could be interacting with the probe in ways we've never seen before. If these forces are influencing its signal, this anomaly could be our first real-time clue about conditions out there. And yes, for the public, the word signal inevitably sparks talk of aliens. Scientists know this, but they're careful. The focus right now is on testable, natural explanations, not speculation. If there's one thing Voyager's journey has taught us, it's that space is full of surprises, and the truth, once uncovered, is often stranger than fiction. Right now, Voyager 1 is in a place no spacecraft has ever gone before. More than 15 billion miles from Earth, deep in interstellar space. Out here, the sun's magnetic field has faded into the background, replaced by the raw, unfiltered environment between the stars. It's a region filled with high-energy particles, strange magnetic currents, and cosmic radiation, conditions we've only been able to study from a distance until Voyager crossed the heliopause in 2012. The importance of this new anomaly isn't just about the signal itself, it's about where it came from. Every piece of data Voyager sends back is a direct measurement from a completely uncharted frontier. There's no guarantee that our expectations about how space behaves out here will hold true. Some of the phenomena could be entirely new to science, driven by physics we haven't yet encountered up close. Yes, Voyager has had glitches before, from faulty instruments to corrupted telemetry, but this feels different. This isn't just a garbled readout or a misfired sensor. It's a consistent, repeating pattern arriving from a spacecraft that's still functioning after nearly 5 decades. That consistency makes engineers pay closer attention. In short, this anomaly is a reminder of two things: how fragile our link is to this tiny probe in the void, and how much we still don't know about the space between the stars. Every transmission could be Voyager's last, or it could be the start of a discovery we never saw coming. It didn't take long for the news to explode online. Within hours of NASA's confirmation, space forums lit up with speculation, science bloggers pushed out breakdown videos, and mainstream headlines swung between cautious reporting and sensational alien signal teasers. On one side, you have the skeptics, engineers, scientists, and veteran space watchers calling this exactly what it might be: a hardware issue from a probe nearly half a century old. They remind everyone that Voyager 1 has survived decades of cosmic radiation, extreme temperatures, and countless minor glitches. To them, this is likely just another technical hiccup in a long line of repairs and resets. But on the other side, there's a wave of curiosity and excitement. Space enthusiasts point out that the signal's pattern doesn't match previous errors, and conspiracy channels are already floating ideas ranging from unknown cosmic phenomena to, you guessed it, intelligent contact. Memes are flying, Twitter threads are going viral, and Voyager anomaly is trending in multiple countries. Some see it as the beginning of a scientific mystery worth solving. Others see it as the perfect setup for a sci-fi plot. But no matter which camp you're in, one thing is certain: Voyager 1 has once again captured the world's imagination, just like it did when it first left Earth in 1977. At NASA's Jet Propulsion Laboratory, the moment this anomaly was confirmed, engineers began reshaping their entire listening schedule. Deep Space Network antennas are now dedicating more time to Voyager 1, trying to capture every faint transmission the probe sends. Every single packet of data is being scrutinized, compared against decades of archived signals to see exactly when and how this new pattern emerged. Troubleshooting, however, is anything but simple. Voyager 1 is more than 15 billion miles away, and even a single command takes over 22 hours to reach it. Another 22 hours for the reply to come back. That means every adjustment, every test is a multi-day process. And with the probe running on minimal power, engineers have to be extremely cautious about what systems they activate and how long they keep them running. The team is now running parallel investigations, one focusing on possible onboard hardware issues, another on external space environment factors. Specialized algorithms are also being used to clean the signal in case the anomaly is hiding in the noise. As for a timeline, NASA isn't making promises. The earliest results from their first targeted tests could come within a few weeks, but a full explanation might take months, and there's always the possibility that this mystery will remain unsolved. If the signal turns out to be something extraordinary, the data will make that clear. Until then, the world waits. listening to the faintest voice humanity has ever sent into the dark. As Voyager 1 sails through the silent darkness beyond our solar system, every signal it sends is more than just data. It's a voice from humanity's farthest frontier. For 48 years, it has pushed the limits of engineering, outlasting its original mission by decades, and giving us a view of space no other probe has ever reached. This new anomaly, whatever it turns out to be, is now part of that legacy. It might be a simple glitch, a side effect of deep space's harsh environment, or perhaps a clue to something we've never encountered before. But either way, it will be remembered as one of the final great mysteries Voyager 1 has gifted us. The truth is, its time is limited. Power reserves are dwindling, instruments are slowly shutting down, and eventually, its voice will fade into the cosmic background. When that day comes, it won't be the silence we remember. It will be the incredible journey, the golden record carrying our message to the stars, and the fact that, for a brief moment in history, humanity touched the edge of interstellar space. Voyager 1's faint signal still travels across the cold void, taking over 22 hours to reach us, each bit carrying the story of a machine that has gone farther than anything we've ever built. This anomaly might be its final mystery, or the start of something no one expected. Whether it turns out to be a glitch, a quirk of deep space, or a glimpse into something entirely new, it reminds us why Voyager exists: to push past the known, to explore the impossible, and to show that even at the edge of darkness, there is still something worth listening for. One day, the signal will stop, but long after that, Voyager will keep sailing, carrying our message, our music, and a small piece of who we are into the endless night. And maybe, just maybe, someone or something out there will hear it.